In this problem, we have a current flowing through the bulb of a 3.75 volt flashlight, and a resistance is given for the bulb. So let's take a look at what resistance is all about. A conducting wire will be relatively thick compared to the filament of a bulb. And oftentimes, the filament of a bulb is going to be wound into coils because it's very thin and very long. The thinner it is and the longer it is, the more resistance to current flow it'll have. So this is just kind of a zoomed in picture of the flashlight. This part is called the bulb filament. Now in a circuit diagram, bulb filaments will be represented by this symbol. That can actually stand for any resistor. Okay, resistors don't have to be light bulbs. They could just be materials which don't allow current to flow very well. To make it clear in a circuit diagram that it's a light bulb, we would put a circle around it. And this is just a very simple diagram of a flashlight. But we want to look at what's happening in a close-up view. We said before that a battery will create a potential difference in our circuit. Now our bulb is going to have a resistance R, and that is the 3.30. The unit of resistance is Greek omega, which stands for ohms in this case. And we also want to figure that the resistance of our conducting wire is very small, approximately 0. So the main obstacle to current flow in this situation is the bulb filament. And we can use what is called Ohm's law to find the current in this circuit. Ohm's law can be written in one of many ways. One way to write it is delta V equals I times R. That's its most well-known form. We can also, of course, rearrange for the other variables. And I'll just use this middle version of the formula here because I know the delta V and the R. Alright, so let's solve this for our problem. We'll put our voltage on top. And our resistance of the bulb on bottom. I get 1.14 amps. So the more resistance there is, the less current will flow.